Thank you, everyone, for tuning into the Cloud Native FM podcast. And today we're speaking and talking about a very, very important topic of today's time platform engineering. Let me give you some insights about what we are covering today. According to the 2023 State of DevOps report, after adopting platform engineering, the majority of enterprises saw improvement in system reliability, 60%, productivity and efficiency, 59%, and workflow standard, 57%, while 42% reported improved development time. But what is platform engineering? A platform engineering is responsible for reducing developer cognitive load while interacting and delivering software. But platform engineering is all about supporting developers and it's bring together experts from various fields in your organization to form a powerhouse team. And often people describe platform engineering as all about support a specialized field that focuses on creating and maintaining infrastructure and services that support the development and deployment of software application. And there are tons more I can drill into, but I will pause here and let me introduce my guest today. Join Alexis Richardson, CEO and co-founder of Weaveworks. Prior to Weaveworks, Alexis co-founded RabbitMQ and was also the technical oversight committee chair at Cloud Native Computing Foundation for 3 years. So without further delay, let me straight go to Alexis. Thank you very much, Alexis, on the podcast today.
Hi, can you hear me?
Yes, absolutely, perfectly fine. So can you tell me a little about your stuff today? We are busy these days, and then we start this agenda of the for the podcast.
Sure, I'm very busy these days. I moved from London to Oxford. I'm sitting downstairs here in this little room. We have a distributed team, so I come here to do this sort of podcasts and calls. We're doing a lot now with platform engineering everywhere in America, in Europe, and elsewhere too, mostly using Flux and Kubernetes, but also Backstage, secrets, security policy coming together in lots of different ways, modular ways to make a platform for people. And what I'm seeing is there is no one platform. There are lots of different platforms. Everybody's got one. In fact, some people have several.
Absolutely, 100% true. So let me start the discussion today. Let us know, before starting other topics, what is platform engineering from your perspective and how it's different from DevOps?
Well, let's start with what is DevOps.
Yes.
So I may be wrong about this because DevOps started in around 2005, 6 as an evolution of people using Subversion. And not long after that, they started using Git and starting to think about how they could make work less manual for operations and standing up websites. If you think about what happened in the 90s, we went from one kind of IT to another with the arrival of the web. And I still think that the best analogy for today, cloud native, is the arrival of the web, new technology, new standards, a whole new industry, new killer apps, new tools and everything. We're seeing that now with this explosion of cloud native devices, drones, and now, of course, AI as well is going to empower an unthinkably large new generation of developers. And a very small version of that happened in the 90s when the web landed. And then suddenly people started saying, well, hey, let's build websites like Amazon. Let's sell books. Let's try and build apps on phones. It was really crap in those days. But little by little, people started to realize that there was a simple way to build a website with a database, a web server, what we would now call an app server as well, and other components, sometimes rich front end. All of that used to be new once upon a time when we were young. And this was a time before broadband internet, when 9.6 baud was exciting for some of us, and using the internet was noisy. It would go beep, beep, beep when it was connecting. And what we learned was that once you've got a website up and running, if you start to add customers, it becomes really important to keep that website up and to have simple programmatic ways for fixing things when they go wrong. And in really big companies like Google or Amazon, which I think, were part of the overall DevOps trend in the sense they pioneered early automation, the automation of operational processes that became DevOps, hooked up to Subversion and Git that became DevOps for deployment. Let's fix the system before it's too late. The system is down. Let's roll out a change. Let's roll out a change at night, but we have to have a rollback strategy. How can we make this systematic? How can we make it programmatic? How can we make it automatic? It's like Danny in Greece. And eventually, like Grease Lightning. And then they would have this system which was fast. And it was fast because it was programmatic. And then they would take the operational steps they were making manually and replace them with little programs. And that was in the era of, early things like PHP, Perl. I remember a whole generation of Perl hackers. You don't have Artur Bergman, the founder of Fastly. He was originally one of the main Perl hackers. There was this thing called Sixapart, great blogging website. And all of these places were where these hackers were developing these new early programmatic scripts and tools for automating the operations. And I think that became DevOps. Somebody called it that. I don't know whether it was Andrew, Clay Schaefer, or Patrick, or one of the other people. Let me think. The folks who wrote Accelerate. All of these people were early hackers in the space, and they identified a set of practices which became DevOps and continuous delivery, automation, and continuous integration. The idea was that if you wanted to make tests, if you wanted to roll out a change, test it first, and you should speed that up by making it automatic, and you should be able to do that every time you rolled out a change. So it was around the same tests, and then that would be part of your CI pipeline, and that became continuous delivery. And then instead of writing, scripts, people started to write more complex programs. So developers would take control of operations, and that's how DevOps came to be named. People like Jez Humble, I'm thinking of here, Dave Farley. And all of these people wrote about it at the time. It became a big movement, but it wasn't really a formal thing in the sense there wasn't one thing that was DevOps exactly, nor there was one thing that was Agile, nor necessarily was there really one thing that was CI/CD. But then suddenly, a new app appeared from a Y Combinator company called Heroku. And that was interesting because they noticed that even with these modern practices, deploying a Ruby app was still really difficult. And what was neat about Ruby on Rails, both Ruby, the version that was created by Mads in the 90s, and then the DHH version on Rails that ran a few years later, was actually quite a lot easier than writing a big enterprise Java app. And so for many people who didn't want to have to do too much work to learn how to program just a website or a web app to make money, Ruby on Rails was a logical thing to do. So there was this culture of, hey, let's do continuous delivery to continuous deployment. Let's do DevOps, but let's do Ruby on Rails. And these three people who became the Heroku team, James, Adam, and Orion, said, wait a minute, this could be a lot easier if we just made everything that we're doing through this DevOps operational culture work in the cloud. We're using the same sort of concepts as Ruby, the same rails, the same guardrails to stop you doing the wrong thing and keep you on the right track. The same CLI-based system where I can see on a screen, but I also type at a command line, so I'm actually interacting very fast with the system in a very simple way, and I get very quick feedback on what's happening. All of these ideas came out of DevOps, but Heroku was a very specific thing. It was a new kind of thing. It was an application platform in the cloud. And of course, I didn't say it, but it would not have happened without EC2, on which Heroku lived. And probably Heroku wouldn't have been written if EC2 hadn't been around to challenge people on, let's have lots of scalable deployment, but oh shit, it's really hard because DevOps isn't quite easy enough for Ruby hackers, so let's make it even easier. So now you have an era of what became called platform as a service. And people said, wait a minute, there are three things here. There's the applications, and then there's the tools to run the applications, and then there's the infrastructure to run the tools. SaaS, PaaS, IaaS, and then suddenly you have people doing podcasts and interviews and analysts and newspapers talking about these things, and it's an industry. So now you have PaaS, and then somebody called Paul Fremantle, I think it was the first person to say, this is a cloud native platform. This is like application platforms before it. Remember, I mentioned Java briefly. And you should know I also ran the Spring team for a while in between Rabbit and CNCF and Weaveworks. We have this era of app platforms in Java, on-premise and self-hosted systems. And Paul Fremantle was at WSO2, which made one of these web app platforms. And he looked at Heroku and he looked at what they could do with the existing Java tools. He said, this is the same idea. It's a platform. It's a place where all of the infrastructure is present to run the application, but it's in the cloud. So we call it platform as a service, and it's a cloud native platform. And so that was really the beginning of what we call today platform engineering, because people were building and running these things, except in that time, Heroku was a vendor and Paul was working at WSO2, another vendor. And I remember giving talks, and I was at VMware by then. They'd acquired Rabbit. We were building Cloud Foundry. That was another vendor. So you've got all these vendors doing vendor stuff. Vendor. Very unexciting for users, but suddenly a few years later, we have a second generation user-driven platform. That's what platform engineering means. You're on mute.
Thanks, Alex. It's wonderful, short, skinnier, but it's make a lot of the sense for me, and I hope for the viewers as well, how these things eventually rolled out. So let's talk about this. Like you talk about infrastructure as a service, platform as a service. Now we call it function as a service. We call it container as a service. There is plenty of more we can drill into. But let's talk about the Kubernetes, the era that eventually people say generated this wave of platform engineering. Because when you install Kubernetes cluster locally, you don't have ingress. By then you have to install it your own proxies, service meshes, GitOps tool, infrastructure observability and monitoring. You have to require this setup. So what do you think? What does a Kubernetes means for the PaaS model, platform as a service?
Kubernetes makes it possible to have business-specific platforms that are in the cloud or on-premise in a cloud-native automated style without worrying about a lot of the infrastructure work, and in a way that abstracts the application deployment model and lifecycle from the infrastructure, so you don't have to write a special VMware version or an AWS version. In 2010, there was no VMware version of Heroku, it just ran on EC2. And then we made Cloud Foundry, which ran on VMs. So it was OpenShift at the same time. They both ran on VMs on EC2 and VMware. We still have not abstracted completely. And then we had containers, which were running inside Cloud Foundry. There were LXC containers. And there was a company called .cloud that made their own containers out of LXC and put a wrapper around it, which became Docker. And suddenly you have everybody saying Docker container, application packaging and runtime model that I can run across any infrastructure. Let's make platforms this way. But then we still have all this infrastructure to put together, like service routing or discovery and networking. So Kubernetes is really an agglomeration of abstractions to make that automated and manageable. And of course, we know that it came out of Google, but it could have come out of anywhere. The thing that we realized with Cloud Foundry was that it was kind of the wrong abstraction, was because there was a top layer, an inner PaaS, which was similar to Heroku. It ran build packs and 12-factor web apps at the time, expanded to run a few more different models, but it was still restricted because it load balanced through the HTTP server and through the database. You couldn't have arbitrary app styles. And if you looked in the cloud, very few apps that people ran on EC2 would fit into the Heroku model easily. And Heroku was also a bit expensive. So we realized that the 12-factor model was great for some apps, but not all. You have all these other app types like big data or streaming, or now AI, ML ops. These are different things, mobile backends. There were even special companies just doing mobile backends. And so suddenly we thought, okay, could you have a different abstraction? Maybe the provisioning layer could be the abstraction. So then we had things like this thing called Bosch, which is a bit like what Terraform is today, or like Puppet and Chef. And that was almost better, but it still didn't give you enough to the team. And if you ask, what is a platform? A platform is really an abstraction that separates the concerns of app developers from what we call platform operations. Consolidated shared operations that can be reused across multiple app types. That's the platform. And so what Kubernetes is, it's a platform, but it's also, as Joe Better said, a platform for building platforms, because it gives you enough infrastructure management and container management that you can run containerized applications in the same kind of way across many different business use cases. And so if Kubernetes can be run on Amazon and on VMware and on Metal, you have a way that can run across pretty much anything, which is the same, and lets you think about the app platform on top of the Kubernetes infrastructure management container lifecycle tool. And so Kubernetes represented a logical innovation, a consequence of people trying to find the right abstraction layer for managing containers in a cloud native way across different infrastructure. But then it was still too complicated because it wasn't specific to one particular business model. If you wanted to run mobile apps, you would use one set of tools. If you wanted to do data science, you'd use another set of tools. You wouldn't use a Jupyter notebook for a mobile app. So you would have this concept of mobile platform and data science platform and web app platform. Kubernetes could run all these things if it was given the right components to run for you. But somebody had to choose those components. Somebody had to say, I want to run web apps, so I'm going to use Prometheus for monitoring, Fluent for logging, EC2 for underlying infrastructure, Kubernetes to orchestrate, and I need these other things. So that person who's making these decisions, that is your first platform engineer. And actually, they may even be building their own app. And I think this is one of the things people need to understand today, 2023, about platform engineering. If you are an app developer and you're building your first app and you want to run it on EKS in the cloud, for example, or on Tanzu Kubernetes on-prem maybe, then you're making these decisions about how much Kubernetes to use. There was a really great interview with Stefan Prodan and Brendan Burns about this a few weeks ago. And Brendan and Stefan were agreeing there isn't really a platform engineering tool, because what people do is they take Kubernetes and Flux, which is inside Azure, and they just use it. And then they start adding things one by one to run their apps. And then what happens is, after they've added a few things, they go, wait a minute, this is getting boring. I feel like I'm doing a repeated manual labor. I need to automate this. I need to make it systematic. And that decision to make two things work as one, or to make a pipeline work automatically, or to have certain checks automatically, these automated workflows, these are the platform that is emerging from the app. So you start with the app, you start making it better and bigger and more used by a bigger team, and suddenly you start to make things automated, programmatic, systematic. And now you have the beginning of a platform coming out of the app, like a kind of monster out of a shell, out of ripping off the skin. Now there's a platform inside, because what you've discovered is there are parts of your app that you can reuse and make systematic. Also, if you have an app that has a lot of users, you might have a dedicated operations team, or you might have people with operational responsibilities. So you start to say, what is inside the app? The Kubernetes pieces, the Kubernetes SRE team, what are the things they have to understand about how Kubernetes is behaving? And that becomes the platform team, and then that's separate from the app team. And at Weaveworks, we discovered this all. We went through this journey ourselves. We founded the company. We did container networking. We did container management. We did container monitoring. We offered that as a SaaS. And then we said, okay, how are we going to run this? And we had this big mess that was proprietary. And then we said, okay, this is ridiculous. It's not working. It keeps breaking. how do we make it better for ourselves? How can we make it cheap to run a SaaS in the clouds so we can actually help users make money? And so the first decision we made was to stop writing our own container management logic. And at the time, we had Docker Swarm, Nomad, Mesosphere, Mesos, there were Marathon from Mesos as well, and Kubernetes. And we talked to all these different teams, and we went to the HashiCorp team, and it was on Nomad version 0.1. And they said, you would be crazy to use Nomad. This is a while, like 2016, 2015. So we decided not to use Nomad. Then we went to talk to people using Mesos, and they said, running Mesos is like hammering jelly into the table. It's just too abstract. And then we talked to the Docker Swarm team, and it was clear that Docker Swarm wouldn't be production ready for a while. So that left us being forced to use Kubernetes. And it's really important. You said why Kubernetes matters. It's because the only thing left that actually works. And people say, well, it's too complicated, and it has a stupid name, and you can't understand it. And these things are all true. They're all 100% true. Yes, it has a really stupid name. Yes, it's far too complicated. No one can understand it. And it can be a lot easier, that's for sure. But when you take into account a lot of things you do when you're running a SaaS in the cloud, it actually is the better tool. It was in 2016. Some of these other tools have become better recently, I guess. And this is complementary to things like serverless, of course. They're not alternatives. And so now you're running this thing because you had to. And you suddenly find that actually it is making your life easier. Suddenly we can roll out changes faster. We're thinking in terms of services, not just VMs and containers. We're thinking in terms of apps and services. We're thinking in terms of rollouts. We're thinking in terms of rollout strategies and DR and all sorts of operational things in a whole new way because we're using Kubernetes. And this is how GitOps came about, because we realized that we could deploy automatically using agents, and they would automatically verify that we're always running the right system, and we were secure, and that became how we did operations. But that's for another day. Today, we're talking about platform engineering, which is just one way to use GitOps. And what we found at Weaveworks using platform engineering and GitOps was, yes, you have these separation of concerns. So you start to have one group of people who understand how Kubernetes is working, and they can fix issues when Kubernetes is being bad or naughty. This is in early versions of Kubernetes. And you have another set of people who just roll out apps. My CTO, Matthias, came into the office one day and did some tap, tap, tap. And then he said, and he came over and said, Alexis, I've just managed to deploy an application to our SaaS. I've made an edit to the SaaS that we're selling to customers, and I still don't understand Kubernetes, and I really don't want to. And I thought, okay, this is great, because we've achieved the separation. We have one person who wants to solve a business problem, and we have another group of people, a lot of them are ex-Google, ex-Heroku type SRE people, and they love messing around with the infrastructure. So we've got this separation. The infrastructure people have automated the workflows systematically, programmatically, automatically, to make this platform thing that rolls out the Weaveworks SaaS. And then the SaaS itself sits on top of that, and there's various different capabilities that it has that we can enhance over time. So now we have a roadmap for thinking about the SaaS. And that means we've done platform engineering, even as a single team with one SaaS app. Now, of course, many people who talk about platform engineering now, the real problem they are trying to solve is not just one SaaS app with one small team helping people in the cloud 24/7. So what's the change? So this is really, really important. In platform engineering at scale, meaning a large bank or a telco, or any organization with more than, let's say, 50 engineers, I would say, working in a single environment, you start to think, okay, if I add a new capability, does that mean I incur cost in proportion to that new capability? So let's say I want to add a new feature to help my users. Does that add more cost to my base? If you have a platform, what you should see is that the platform remains the same, but you can add new capabilities without changing the platform. Not much anyway. Most of the time, the platform stays the same, still does logging, still does monitoring, still does writing to disk and recovery, and tells you when it's up and down. The only thing you might need is to have more resources to run on. But other than that, The platform is a consistent, programmatic, systematic, automated set of workflows for you. You can keep adding apps, app developers, new services, new initiatives to it without any increase in the platform complexity and cost. So that's the economic benefit of having a platform. And it works exactly the same economic way as Heroku or Cloud Foundry or OpenShift 10 years ago, except now it doesn't have to be what Heroku team decided was the platform, or what the Pivotal team decided was the Cloud Foundry platform, or what the Red Hat team decided was the OpenShift platform. It's not a black box. In fact, it's our own platform. So Kubernetes is the super tool for power platform builders to make this kind of multi-app, multi-team, multi-service solution on which they can systematically, programmatically, and automatically run apps. And that is really powerful. And again, it's an evolution. It's not amazingly new, but it's really important to understand what is new about it, which is that we do not have to build platforms to someone else's specification anymore. We can build our own choice of platform tools. In practice, there's a lot of overlap across many organizations, some common patterns. But each organization that I've worked with, and I've worked with a lot, has their own choice of tools in their platform. And some of them have several different business cases, data science, mobile apps, machine learning, all of these different things. So they have different platforms, but they're all running on Kubernetes in the same way. And so now we have an industry for platform engineering.
Yes, got it. Absolutely. Perfect way to drill into the intricacies of the platform engineering. But one thing during the conversation, what I've noticed, and correct me if I'm wrong, so usually when people work with the platform as a service model, they don't think about the customization of the platform. They think about the customization of the app. They are actually locked into the platform. They actually have set of tool integrated into the platform, and then they deploy application on top of it. But
Yeah.
what Kubernetes platform does is like is give you some core set of functionalities rather than the vendor lock-in or the vendor lock-in system. You have interfaces and you can add your tooling, add your favorite tooling on top of the past platform, and then you actually customize the platform as a service.
Yeah,
So what
each platform is customized in Kubernetes because Kubernetes is a platform for running platforms. And each one of those is a custom platform for a specific organization and business case. And each one of those platforms is then used by application developers inside those organizations or as a PaaS in the cloud. But the app developers often don't want to see the abstractions. They don't want to see what's behind the curtain. So I think the property you talk about of escaping from the box is a modern property of platforms in 2023, but usually it's a break glass situation. Actually, you only break the glass if there's a genuine emergency. If you're an app developer and you've been given guardrails and you're running happily, everything should be fine. But sometimes you want to do something which breaks out of your box, and then you want to have sometimes the ability to change things. It varies from platform to platform when you do this, but it's very different from the so-called completely opinionated vendor platforms where there's no break glass opportunity at all. And actually what I see is really 3 or 4 different tiers of abstraction. So at the bottom layer, you have the Kubernetes container as a service capability, usually for one vendor or several vendors, but it could be running on VMware or EC2 or across 2. Often you have people who want to have the option of running both on VMware and on EC2, for example. Then on top of that, you have the core platform. That's the piece that chooses the monitoring, chooses the logging, is integrated with the organization's security and other common services. And then above that, then you have some customizations for different business cases. So the second layer is about providing a sort of stem cell platform. And then we extend that into a real living cell for different platform cases by customizing it. And then finally, you have the top layer abstraction, which is what the app developer sees, where they would actually prefer to not have to do any customizations themselves. So I've seen a lot of companies who have the field of dreams problem, which I thought I saw somebody wrote a blog about this as well. But so the platform engineering team spends a lot of money building a platform, making it work really nicely, and then they can't understand why the app development teams don't all start using it. Because the ROI of that work comes from the app teams using it, from the automation benefits they get, and the scalability and the security. And so how do you onboard these people if they're not sure if it's trusted or safe to come onto the platform? They will tell you, well, your onboarding is too complicated. I don't want to have to write a Terraform plan to come onto the platform. I don't want to have to understand Kubernetes YAML. I don't want to have to change Vault secret settings. If you hear that from your users, that means you've got the abstraction layer wrong. But actually, what users want is, at least to start with, not to think about those YAML files, not to think about config. Just let GitOps take care of it for you. We'll template it. We'll have dependency management. We'll automate all that shit away. That's GitOps platform engineering. But unlike with the old days of Heroku and Cloud Foundry, they do want to break glass sometimes. So once the app is up and running, they want to be able to say, oh shit, actually, this app might need access to something else that's inside the platform that we didn't expect. Can you, platform engineers, change our application tenant so that it has access to that service? Because we need some new capability. Maybe we're using we just bought a load of NVIDIA chips, and we want to do something AI training or something on those chips, but we don't have the right tools available in the app, API inside the platform, make a change. And the platform engineering team should hear that from the developers and say, great, we'll make that change for you really quickly. And if you have that turnaround, that agility of the app developers are happy because they live in happy, productive, on Rails world, but also if they need a change, they can ask for it and the platform team will give it to them, or sometimes they can do it themselves. Then you have the benefits of platform engineering because you have a high performance, custom platform with agility, automated DevOps, and so on, but without forcing everybody to only do what they're told, which is the original black box platform model.
Yes, got it. And I think and then I think that's all conversation will lead up to the next conversation we got. Like usually you can't change or think about changing the platform itself. But now the Kubernetes give you the customization and the abstraction layer is basically building a platform on top of platform. So basically this means you can customize it. And then there's a conversation started around developer experience with Kubernetes, with the platform, and with the self-service capabilities, because now and that's conversation will lead up to the forward thinking with the platform, meaning there's a two word right now, the one word that's outside of the Kubernetes and one word that's inside the Kubernetes. I see a lot of the team investing time to jump into the Kubernetes word of outside the Kubernetes ecosystem. And then people do have two things, like they work with the customers that are heavy focused around Kubernetes, and Kubernetes is a paved path for the GitOps, and GitOps is not outside much without Kubernetes. And then there's another word that's called Terraform automation and standard automation word. What they do is doing with Terraform to doing GitOps thing outside the Kubernetes cluster.
Okay, so with GitOps, we have Flux for Kubernetes. Flux drives Kubernetes clusters using CAPI and other APIs. Flux drives Terraform using the TF controller, Flux TF controller. So we can have Terraform GitOps as well as Kubernetes GitOps. Amazon created CloudFormation integration with Flux. So we have Flux CloudFormation. So you can do Lambdas for GitOps as well now if you want. And there's a whole lot more besides. On top of that, we can have Flux and Argo, Flux and Backstage, Flux and Terraform, Flux and Pulumi, Flux and Crossplane. So Flux becomes the center for automating all these things around you. But you made a really, really great point, which is most people do not want to be 100% inside Kubernetes. And I think that is one of the things people are getting wrong with today's platform engineering online talk. As a lot of Kubernetes is the platform of platforms, now we need to have a platform of our own, custom built, three different golden paths, all enabled on the Kubernetes platform. And that's great until you talk to a customer in the real world and they say, we've got these legacy services outside Kubernetes. We've got databases, we've got VMs, we've got services we can't even move. How do you connect the shit up to the Kubernetes app? And the answer is don't use Spinnaker. The answer is to use a platform tooling that can speak to both Kubernetes and the external services. So therefore, Terraform, Flux, Kubernetes is a great combination. I went to a wonderful talk 2 weeks ago by a guy called Chris, who's now at Upbound. He was at Dresdner Kleinwort Bank, one of the big German organizations. He showed a fantastic platform made of Terraform, Flux, and Crossplane, Flux, and EKS. And so that's the kind of different patterns that we see at Weaveworks of these different GitOps integrations outside Kubernetes and inside Kubernetes together as a single platform engineering solution. So that's one really important point. The second point you made is about self-service and developer experience. Please, can you find me somebody who says the developer experience for Terraform is great? It's not great. Not if you're a developer. If you're a DevOps person and you like YAML files, great, fine, go nuts, or HCL files. We love Terraform here at Weaveworks, but we know that Flux and Terraform and Kubernetes, and we have this product, Weave GitOps, by the way, which is an open source platform engineering toolkit that makes all of this stuff super easy to do. But it works for Terraform. It'll pull it in for you if you want. And then people say, well, that's great, but that's fine for setting up my platform. Now give me developer experience. Self-service. So what you want there is, remember I said there are 3 or 4 layers. You've got infrastructure, Kubernetes, containers as a service, and the core platform, and then the different customized platforms and the apps themselves. So you can give the app developers a tool like Backstage, for example. And now they have a way to look out across the estate. They've got legacy services, they've got Kubernetes services, they've got not Kubernetes services. And as a developer, they can plug and play things. They can use templating to set up things in a specific way. It's like a Power IDE, really. And this gives them a way to centralize the workflows that they need to do to be platform users. So I think typically what we're seeing at Weaveworks is a lot of people getting stuck once the platform works and then struggling to get developer experience to work. And we help them by either creating golden paths onto the platform or by working with a tool like Backstage and Weaveworks, which is integrated, so they can use them together. And so that's why I think you're right. Self-service developer experience, incredibly important and a big part of platform engineering. But I would say, before you get to that point, also think about whether it's inside Kubernetes only or outside and inside Kubernetes.
Yes, that's super important. That's super important. And I think on adding to this question, like you have worked with the wonderful companies and open source tool and the foundation, open source foundation, and you have a great experience over the years working on working with very critical team and critical open source, and you led open source adoption skyrocketing at Flux. And that's a very important question. I think one of the best person to ask this question right now, if I am a person or who has wanted to start up my company and I want to adopt Kubernetes and to give people and want to solve a real world problem, the real business use case with Kubernetes, what should be my forward thinking should be around platform engineering and Kubernetes in general? Because there is a lack of educational and a lack of roadmap. Because when you start adopting Kubernetes, you have to think about, do I have to create anything myself, or do you have to buy Kubernetes off the shelf? And if you buy our Kubernetes out of the shelf, how much services you needed? Do you need service mesh? Where should I go? I need GitOps. Where should I go? I need a monitoring and observability. Where should I go? And there's plenty of other tools that I needed but currently there's a lack of roadmap. What do you suggest? The best forward thinking approach for people who are just landing up to this world of platform engineering?
I would say that for a large organization where the number of apps and teams is at least 50 developers, multiple apps, there are vendors like Weaveworks who will help you make these decisions based on your use case, because there isn't a single way forward and everyone has unique problems. That's why they don't just go use Heroku. That's number one. If you are different from the norm, and everyone is, then typically get some help. But there are also patterns. So people like Amazon and Weaveworks publish patterns, and we are making more patterns available and policies through things like our catalog. If you just come and talk to us, we can share patterns with you. We do a lot of work with Amazon where there are blueprints and open source frameworks which solve this problem for you for different use cases. But I think you're right that at the level of smaller teams, there isn't a one size fits all out of the box answer. There isn't a Heroku equivalent for the modern Kubernetes era. What I would say to people is don't try and do too much. Keep it really simple at the beginning. So for me, the platform journey, if you're a developer sitting there going, I'm going to build a platform, what service mesh should I choose? You've made a mistake already. You should not be worrying about what service mesh you should use. You shouldn't be thinking about building a platform if you're a developer or just one team. I would highly recommend build the simplest possible containerized applications that you can. So that is why we see a lot of people with EKS, Flux, and a couple of other pieces. Adapt the Flux dashboard with GitOps, for example, either Terraform or Crossplane from external services, and that's it. Maybe then they hook up to some kind of secrets tool. And then it evolves over time. Let it evolve. That's the key thing. If you need to have, for example, if you use Flux with CloudFormation, we can set it up so that it automatically connects up to the app mesh. So you can have MTLS. But if you don't need that, don't worry about service mesh. So I would say, don't try and dream the ultimate platform. You're over-engineering it if you're operating at small scale. But if you're in a larger organization, you already have scale, or you've got a lot of users, or you've got a lot of pressure to deliver something quickly, yes, it does make sense to work with a vendor. And different vendors, there are a lot of great vendors out there. It's not just Weaveworks. Different people have different takes on what it means to use Kubernetes. And we often work with other vendors as well, like Red Hat, for example, or SUSE. We work side by side. You've got to ultimately, if you're the VP of platform or the platform owner, you've got to think through, what is my business goal? Am I trying to go faster here? Or am I trying to get the organization to move every app into the cloud? Or am I trying to retire some old software? I don't need Jenkins anymore. I want to move to modernist software lifecycle. Think about that first before you start picking which vendor to work with and which platform to use. Otherwise, you end up building all the wrong stuff. And then you'll have the field of dreams problem that you've spent all this money, you built a platform and nobody's using it and you don't know how to get them on board.
Yes, absolutely. I think that's super important to have at this moment of time, like the forward thinking with platform engineering. I think that's really important to a small organization to take a look at it, not as Alexis said, not engineering and things like everybody needs a service mesh, network policies or policy as engines. You have to think about it. Otherwise, you have a platform engineer you think is a better, but you have very less customer to user as a user for that. I think that's very important to think about it. So I really enjoyed the conversation a lot, Alexis. But let me know the final few questions from your side, from my side. Like you tell me how the platform engineering over the years, how evolved, like how the DevOps movement eventually started, how to tell about the Cloud Foundry and some bunch of other tools on that movement of era. But few words about what role has WeWork company and your company played in shaping this evolution?
Um, Well, I think we've been very strong advocates for being pragmatic and not having a one-size-fits-all approach. We prefer software that is modular. Don't use something if you don't need it. Use only the pieces that you need. We've been strongly in favor of starting with open source, and then when you get to a place where you need support or help, then bring in commercial vendors, not before. Start small and grow. We love that sort of thinking. We've also, of course, been pioneers around this terminology of GitOps. And nowadays, people will tell you that GitOps use cases are platform engineering, CI/CD, policy as code, infrastructure as code. And those are really important. All of them are needed for managing large numbers of workloads and applications in the cloud. So we feel that we've been in the middle of that discussion. With Flux, we have a tool that's been, I think I checked this week, the SHA image keys for Flux have been downloaded more than 4 billion times. 4 billion. That's big. It's inside Azure, it's inside Amazon, it's inside Tanzu, it's inside GitLab. These are at scale, massive footprints. So really, we're very excited about how Flux has transformed how people think about application deployment. But there's so much still to come, because we're now starting to understand with platform engineering that this is how we're going to democratize. And I should not use the word democratize. This is how we're going to open up, simplify, and bring together all these different developers with different skill sets, with different use cases into ways of using the cloud better. And I think that's the really exciting next step.
Absolutely, absolutely. I really enjoyed the conversation a lot, Alexis. It's been a pleasure talking to you in this episode, and you shine light on very critical area on this podcast. Hope this will conversation helps a lot of people who are listening to us. And if you are into the Flux tool, and one of my favorite tool in the CNCF tooling, I've been into this tool for a very long time. I've done a podcast with Stefan Pradhan during when this project is graduated in CNCF, and he shared a wonderful journey of how this project is graduated. And if you look at the list of adopter, you are amazed to see how many of the companies are using it for the real world. That's really inspiring for all of the Flux community. Plus, the Flux, I think 2.8 GA, Flux 2.0 or Flux GA.
Yeah. Flux 2 is a superpower tool, which people have been working with for several years now. And all of the user feedback into Flux 2 has made it into the incredibly production-grade, high-scale, secure solution that it is now. And it's heading GA. And what we've done with Weaveworks is build all these extensions around it so that you can do this platform yourself. So we're very excited.
Awesome, wonderful, wonderful. So final and let's and has to wrap up. What is platform engineering again, and what isn't it in a very few sentences and words?
Platform engineering is how we simplify computing for every developer in our organization by creating environments for them to run their apps. Those environments are the platform, and the job of the platform team is to choose how they are built and where they run, and make sure they're always available in an easy way. And separating those concerns between the automated platform and the app developers who have an easy time, that is platform engineering.
Oh, super. I think I find one of the best definition in the internet. Wonderful, wonderful. Thank you very much. Let me wrap up here, because we have discussed so much of the topic here. The advent of the cloud computing and infrastructure as code, DevOps and continuous delivery, increasing complexity and scale, need for standardization and efficiency, with the growing importance of observability and monitoring, the rise of containerization technologies like Docker and like Kubernetes contributed to the need for platform engineering. Effective collaboration, communication, leadership skills to guide teams, make strategic decisions, manage resources effectively, and drive project to success are the key skills that platform engineers should possess, or at least adhering to. A platform should should processes possesses capabilities include not limited to standardized automation, consistent security policies, unified Kubernetes multi-tenancy or access management, single administration pane, or offering observable visibility to the entire infrastructure spanning multiple cloud. So that's
That's
my
all
key
true,
take, but you will.
but it's not one size fits all. So your mileage may vary, and you may not need all of those things. As
Oh,
they say,
got it. Absolutely.
you ain't gonna need it. If you don't need everything, don't have everything on day zero.
Yes, absolutely. 100%. I 100% agree. I think you read my mind. I'm actually ending at the end. But thank you very much, Alexis. It's been a pleasure. Every time I see your talk, it's ton of inspirational content, and you really scratch the surface for all of the leaders and the readers who are actually listening to us. But once again, thank you very much, everyone, for listening to this show. We will meet again soon with
Thank
another
you.
guest here on Cloud Native Podcast. And tons of thanks to Alexis again. Stay safe, stay healthy. Have a wonderful day, everyone. Bye bye.